Hello children, how are you all? How, how are you all? I hope you are fine, yes? Have you finished your work? Have you finished your work, children? Okay. Did you do the homework? Did you do yesterday homework? Okay, children. You finish your work. You do your work. You study. Whatever you have written in the classwork, whatever in the book, you have to study. Okay, children? Now, we have to start today class. State of matter based on kinetic energy. State of matter based on kinetic energy. Already you know what are the states of matter. That is solid, liquid, then gaseous, then plasma we have studied, then that Bose-Einstein state, that is the fifth state, that is the fifth state. Today, each states of matter based on kinetic energy, we will study one by one. We will study one by one. Now, children, solid state. First of all, we have to see solid state. The particles in the solid state are closely packed. Already you know. What you know? What are the differences between the solid, liquid and gaseous? So what are the difference between the solid, liquid and gaseous? So here the solid states of matter, solid based on kinetic energy, the particles in the solid state are closely packed. The particles in the solid state are closely packed. That is the interparticle space. What is that? The interparticle space is negligible. The interparticle space is negligible, so that we cannot be compressed. So the solids cannot be compressed. The solid states of matter cannot be compressed because the interparticle space is negligible. The interparticle space is negligible. Next, strong force of attraction between the particle. One strong force of attraction, so that the interparticle space is so that the particles are closely packed. Particles are closely packed in the solid state because strong force of attraction. The particles, they attract one another with a strong force. So next point, particles only vibrate about their mean position. Particles என்று சொன்னால் துகள்கள், in Tamil meaning துகள்கள். அவற்றின் சராசரி நிலையை மட்டுமே அவைகள் என்ன செய்கின்றது? அதிர்கின்றன. So particles only vibrate about their mean position. அவற்றின் சராசரி நிலையில். Vibrate அதிர்தல். Particles துகள்கள். So துகள்கள் அவற்றின் சராசரி நிலையில் மட்டுமே என்ன செய்யும்? அதிரும். So that particles only vibrate about their mean position. The next one, particles are arranged in a definite manner. Particles are arranged in a definite manner. Now, particles, all the particles of the solid matter, otherwise the particles in the solid state are arranged in a definite manner. Then kinetic energy of the particles of, next one, kinetic energy of the particles of solid is minimum. Kinetic energy, that is இயக்க ஆற்றல். So here துகள்களின் இயக்க ஆற்றல், துகள்களினுடைய இயக்க ஆற்றல் குறைந்தபட்சமாக இருக்கும். So kinetic energy of the particles of solid is minimum. What is that? Say with me. Everybody open your mouth and say with me. Kinetic energy of the particles of solid is minimum. Then next, now we studied about the solid state based on kinetic energy. Based on kinetic energy. 5 points. We studied 5 points. First, we studied the particles in the solid state are closely packed. That is, the interparticle space is negligible. That's why the interparticle space is negligible, because it cannot be compressed. அவைகளை நம்ம solid state of matter நாம் எவ்வளவுதான் அழுத்தினாலும் அவைகள் என்ன செய்யாது, அமுங்காது. So that is, it cannot be compressed. That is, it cannot be compressed. Now, liquid. Next, strong force of attraction in the solid state of matter has strong force of attraction. The next, the particles only vibrate about their mean position. That அதனுடைய சராசரி நிலையில் மட்டுமே அவைகள் அதிர்கின்றன. So about their mean position. Next, particles are arranged in a definite manner. Then kinetic energy of the particles of solid is minimum. Okay, these are in the solid state based on the kinetic energy. So the solid states of matter points are here. Now we will study about liquid state. We will study about liquid state. Look at the slide, children. The particles are loosely packed. And are not as fixed as compared to solids. The particles of liquid state are loosely packed. They are not as fixed. When we compare liquid state of matter compared to solid state of matter, some difference are there. Here in solid state, the particles are closely packed. Here opposite, the particles are loosely packed. Now here, and also the particles can move over one another. They can move over one another. There in solid state, the particles are closely packed. So we cannot be even compressed also. So here you see the particles can move. The particles of liquid state can move over one another. Next point. The interparticle space is more. The interparticle space is more than that in solid. அதாவது solid stateல இருக்கக்கூடிய intermolecular space liquid stateல intermolecular space வந்து அதிகமா இருக்கும். ஆனால் solid stateல intermolecular space என்னது ரொம்ப குறைவா இருக்கும். The interparticle space is more than that in solids, hence are more compressible. The interparticular space is more in the liquid state. That's why they are more compressible. The next point, what the next point tells about the liquid state. You look at the third point. The motion of particles is irregular. And random. What is the meaning of irregular and random? Here you see, what is this sentence says as துகள்களினுடைய இயக்கம் ஒழுங்கற்றதாகவும் சீரற்றதாகவும் இருக்கிறது. The motion of particles in liquid state is irregular and random. Irregular ஒழுங்கற்றது, random சீரற்றதாக இருக்கிறது. Okay, now listen, children. We will go to the next point. Kinetic energy is larger than solids. Listen, what this point says is kinetic energy is larger than solids as the particles move more freely and faster than those in solids. The kinetic energy is larger in liquid state than comparing the solid state. As the particles move more freely and also faster, very faster, the particles movements are more freely and the particle movements are faster comparing what those in solids, Okay, children, now we studied about the solid state and liquid state based on the kinetic energy, Next, we will study about gaseous state. What is that? Gaseous state. We will study about the gaseous state. You look at the slide, children. First point, the particles are much further apart than in solids or in liquid. What? Gaseous state says the particles are much further apart than in solids or in liquids. திடப்பொருளை காட்டிலும் துகள்கள் மிகவும் வேறுபட்டவை. திடப்பொருளை காட்டிலும் துகள்கள் மிகவும் வேறுபட்டவை. So here the particles are much further apart than in solids or in liquids The next, there exists negligible force of attraction. What is that? There exists negligible force of attraction between particles. There exists negligible force of attractions between particles, hence occupies the entire space available. Here, ஈர்ப்பின் மிக குறைந்த சக்தி, where it is in the gaseous state, that is negligible force of attraction. ஈர்ப்பினுடைய மிக குறைந்த சக்தி, negligible force of attraction between the particles. So hence they occupies the entire space available. Because of negligible force of attraction are present in this gaseous state of matter. Are you listening me, children? Can you understand this? Look at me and look at the book. Okay? You can listen. You have to learn with me. You have to listen me, then only you have to understand more. So next point, what is the next point? Says kinetic energy of particles in a gas is very large. Kinetic energy of particles in a gas is very large. Next one, they can easily be compressed. As they are far apart. வெகு தொலைவில் உள்ளன. Which all are very far apart in the gaseous states of matter particles. The next point, before the last point, it is not in the slide. You look at the book, page number 7, fifth point. Fifth point is in gaseous state. Gases exert pressure on the walls of the containing vessel due to continuous compartment. தொடர்ச்சியான குண்டு வெடிப்பு காரணமாக, bombardment. What is that? Bombardment. So தொடர்ச்சியான குண்டு வெடிப்பின் காரணமாக வாயுக்கள் அழுத்தத்தை கொடுக்கிறது. So gases exert pressure on the walls of the containing vessel due to continuous bombardment. The next we will study about changes in state of matter. What are the changes in state of matter. We will study. Now, now look at the slide, children. The process of the changes in state of matter. What are the changes in state of matter? Melting. What is first? Melting. We will study about the melting. It is the process. It is the process. So, the process of change of a solid substance into liquid state. Listen, the process of change of a solid substance into its liquid state on absorbing heat. On absorbing heat at a particular temperature. At a particular temperature. This is called melting or fusion. Listen here. Already you know how the solids, when the solid changes into liquid state. When the liquid changes into gaseous state. You know everything. You know. Here also that same point is given. The process of change of solid substance into liquid. The solid converts into liquid while on absorbing heat. While on absorbing heat at a particular temperature. At a particular temperature. This is called melting. Or another one name is fusion. Another one is fusion. Next, on the basis of kinetic energy. On the basis of kinetic energy, first point, on the basis of kinetic energy, first point, particles gain energy. Particles gain energy. So, we can gain energy from the particles. So, particles gain energy. Next, intermolecular attractions decreases. Intermolecular attraction decreases. The next, intermolecular space between the molecules of solid increases. Here note this, intermolecular attraction decreases and intermolecular space between the molecules of a solid increases. Between the molecules of the solid increases. Now, at the melting point, particles become free. At a melting point, particles becomes free from fixed position. Melting point, when at a melting condition or when at a melting point, when it becomes at a melting point, particles becomes free from the fixed position. After that, it converts into a liquid state. After that, it converts into a liquid state. So, the constant temperature at which a solid becomes liquid at the normal pressure, the pressure is called melting point of solid. Melting point of solid. Did you understand, children? Got it? Okay. Next, we will study about vaporization. What is that? Vaporization. Here the constant temperature at which a solid becomes liquid at a normal pressure is called melting point of vaporization. Look at this. The process of vaporization, that another one name is evaporation. What is that? Evaporation. The process of conversion of a substance. The process of conversion of a substance from the liquid state, to its vapor, at any temperature. At any temperature below its boiling point. Below its boiling point is called vaporization or evaporation. The process of conversion of a substance from the liquid state to its vapor state at any temperature below its boiling point is called vaporization or evaporation. What is this? The vaporization or evaporation is a process. So the process of conversion of a substance, you take one substance, that substance now it is a solid state. Now it is a solid state. So it changes to its vapor state at any temperature below its boiling point. அதனுடைய கொதிநிலைக்கு கீழே, குறிப்பிட்ட கொதிநிலைக்கு கீழே, below its boiling point. That is called vaporization. That is called vaporization. Liquid converts into vapor. Liquid converts into gaseous state. On the basis of kinetic energy, particles gain energy. Particles gain energy. Intermolecular attraction decreases. Intermolecular attraction decreases. Intermolecular spaces between molecules, intermolecular spaces between the molecules of liquid increases. That intermolecular spaces between the molecule, that intermolecular spaces, the small spaces between the molecules of liquid, that is increases. At boiling point, particles become completely free. The particles become completely free and convert into gas, otherwise vapor. The constant temperature at which a liquid becomes a vapor at normal pressure, this is called boiling point of liquid. That is called boiling point of liquid. Now children, next we will study about the liquefaction. What is that? Liquefaction. You look at the slide, children. Liquefaction. Another one name is called condensation. Condensation. Now the process of change of state. What about liquefaction? First of all, we must know about liquefaction or condensation. So here the process of change of state of a substance from it gaseous to liquid. Gaseous to liquid. Vaporization, liquid to vapor state. Liquid state to vapor state. Here from gaseous state to liquid state, that is liquefaction at a particular temperature. Very easy to memorize and very easy to learn. You know more when you listen this. Here you see, so you listen carefully, children. You listen carefully. The process of change of state of substance, the substance change from the gaseous to the change of state of substance, change of the state from the gaseous to vapor, that gaseous to liquid. So that process is liquefaction. Next, on the basis of kinetic energy. Now, the first one, particles lose energy. Intermolecular attraction increases. Attraction will be increased. Intermolecular attraction increases. Intermolecular attraction is increased. Next, the intermolecular space between molecules. Intermolecular space in between the molecule, more intermolecular space is there. So the intermolecular space between the molecules of gases, that will be decreased. That will be decreased. Next, at liquefaction point, particles come close enough and convert into a liquid. So this process is liquefaction. So activity 1, look at the slide, children. On the basis of kinetic energy, particles lose energy. Intermolecular attraction increases. Intermolecular space between molecules. Next, okay, children. Before this, we will study about the activity. We will see about the activity 1 to be demonstrated by the teacher. It should be demonstrated by the teacher. So you see, to show the moisture is present in the atmosphere, many moistures, that the dust particles are present in the atmosphere. So what are the material required? Then only to be demonstrated, this one, the teacher should be demonstrated. The teacher should be demonstrated. So it is not a regular class. You will study. You are studying through the online classes. So listen how we will do. Now materials required. What are the materials required? Glass, ice cubes, water. These three things we need. We need these three. Procedure, take water. First we have to take water in a glass. Put some ice cube in water. கொஞ்சம் ஐஸ் கியூப் எடுத்து அந்த தண்ணிக்குள்ளே போடுறோம். Take water in a glass, put some ice cubes in it. Next, and observe it after 2 to 3 minutes. Then we have to observe it. Observe the outer surface of the glass. Now we have to observe the outer surface of the glass. What is happening? What will happen? Now observation. Tiny droplets of water will be seen. Yes or no? Tiny, that is the small droplets of water. Small droplets of water we can see. The tiny droplets of water have been seen on the outer surface of the glass. On the outer surface of the glass. So now moisture is present in air and it increases in hot, and moisture is present in air and it increases in hot season, increases in hot and also rainy season. It increases in hot. Moisture is present in the air. Moisture, ஈரப்பதம், is present in air. It increases in hot and rainy season also. So when moist air comes in contact with the cold glass surface, when moist air comes in contact with the cold glass surface, it gets condensed. Condensed to form water droplets. To form the water. So how the water droplets comes? When we add the ice cube in the glass of water, water droplets comes. So why? What happens in this glass? Because of moist air comes in contact with the cold glass surface, it gets condensed. So this one proves moisture is present in the atmosphere. Moisture is present in the atmosphere. Now dust particles, that is dust, தூசி துகள்கள், they are mixed in the air. Yes, while breathing time, if the atmosphere is not good, while breathing time, that all the dust particle also goes to our internal body. Yes, so that is, it causes some diseases. So we should keep our environment neat. Now solidification. What is that? Solidification. Now look at the slide, children. Solidification, the process of change of matter from the liquid to solid. Solidification, liquid, that is gaseous to liquid. Now from the liquid to solid state at a particular temperature, this is called freezing or solidification. So on the basis of kinetic energy, particles lose energy. On the basis of kinetic energy, particles lose energy. First, particles lose energy. Then intermolecular attraction increases. In this, listen, on the basis of kinetic energy, intermolecular attraction increases. Then intermolecular attraction here, intermolecular space between molecules of liquid, that is decreases. Next, at freezing point, the last point is not there. So at freezing point, particles start changing into solid. Particles start changing into solid. So this is the process of solidification. Another one name is called freezing. Now children, now we will study about law of conservation of mass. Law of conservation of mass. Listen, in 1774, Antoine Louis, a French chemist, he is a French chemist, Antoine Louis, who is also known as the father of chemistry. He is the father of chemistry. Gave the law of conservation of mass. He gave the law of conservation of mass. According to this law, the mass can neither be created nor destroyed during a chemical reaction. That is, the mass remains constant during the chemical reaction. According to the law, the mass can neither be created, that is not either, printing that mistake, neither be created nor destroyed during a chemical reaction. The mass remains constant during a chemical reaction. It means in a chemical reaction, total mass of products is equal to the total mass of the reactant when they have combined. What they have, that have combined. This time we will study the substances which take part in a chemical reaction. The substances which take part in a chemical reaction are called reactants. What are the substances take part in a chemical reaction? That is called reactants. And the substances, what are the substances formed? What are the substances we get? That are called products. Now A plus B gives us C plus D. So A plus B are reactant. C plus D are products. Now listen children. So here A plus B are mass of reactants. C plus D are mass of products. Now for example, if in a chemical reaction carbon bonds in oxygen, it produces carbon dioxide. In the chemical reaction, carbon bonds in oxygen. You see here A plus B gives us C plus D. It is not printed. Now here mass of reactants is equal to mass of products. Now for example, if in a chemical reaction carbon bonds in oxygen to produce carbon dioxide, the change in mass can be shown by the following equation. Look at this in the chemical equation. Listen, carbon, that is 12. Oxygen, carbon atoms are 12. Oxygen 32. Why? That is 16. 16 multiplied by 2, 32. Now we have to add this 12 plus 32. Look at the book children, page number 9. Page number 9. Look at your book. It is not in the slide, so you look at in your book. Mass of reactants is equal to mass of carbon plus mass of oxygen. Now the mass of carbon is 12. So now the mass of oxygen is 32. So next we have to add this two, mass of carbon and also mass of oxygen. So it becomes 44 gram. So mass of products is equal to mass of carbon dioxide. that means 44 gram. So total mass of products is equal to total mass of reactants. Total mass of reactors. So in this reaction, the mass remains conserved. The mass remains conserved. So we can say that in any reaction, the total mass of substances remain conserved. The total mass of substances conserved. Now listen, that the experimental verification of law of conservation of mass. Mass of reactant is equal to mass of carbon plus mass of oxygen. 12 plus 32, 44 gram. In this reaction, the mass remain conserved. So we can say that in any reaction, the total mass of substances remain conserved. Now, experimental verification of, we will study about experimental verification of law of conservation of mass. Experimental verification of law of conservation of mass. The experiment is done. You look at the book, look at your book, children, and slide only few sentences are there on the slide. So you look at your book. The experiment is done in a specially designed tube called Landols tube. What is that? Landols tube. Sodium chloride solution is taken in 1 limb. Verification of law of conservation of mass. You look at that picture, page, it is in page number 9. Sodium chloride solution is taken in 1 limb of the tube, while silver nitrate solution in the other limb, as shown. It has shown in the picture. So now both limbs are sealed and the tube is weighed. Now the tube is inverted so that the solution may mix together and react chemically. As a result, white precipitate of silver chloride we will obtain. We obtain white precipitate of silver chloride. The following reaction takes place. Silver nitrate, that when you look at this equation, AgNO3, silver nitrate. If I ask, say the formula of silver nitrate, you must say AgNO3, silver Ag, nitrate NO3, okay, 3, nitrate NO3. If it finishes with 3, that is nitrate, like this will come, okay. So here silver nitrate. Next NaCl, sodium chloride, NaCl, sodium chloride. It gives us silver chloride, AgCl, silver chloride, and plus sodium nitrate, So the tube is weighed again and the mass is found to be exactly the same as mass obtained before inverting the tube. This experiment clearly shows the law of conservation of mass is true. The law of conservation of mass is true. So here up to now we studied about this. These all states of matter based on kinetic energy. Then what are the changes in state of matter, melting changes, then next melting, vaporization, liquefaction, solidification. These are we studied. After that, law of conservation of mass. Through the experimental verification also we have seen experimental verification of law of conservation of mass. So we have seen, okay children, so you read this book, you study this book, that book by question, you look at you find the answer from the book, okay children, and also you study. Don't waste your time, you concentrate in your studies. Now I will give the classwork now. Everybody take your classwork note, write the classwork fast. Write the classwork fast, children. fill in the blanks. Take your pen and write fast. Write this fill up fast. First question: the constant temperature at which a solid becomes liquid at normal pressure is called melting point of solid. Melting point of solid. The constant temperature at which a solid becomes liquid at a normal pressure is called melting point of solid. Then second question: the substances which take part in a chemical reaction are called reactants. Chemical reaction are called reactants. Third question: the process of change of matter from the liquid to the solid state at a particular temperature is called freezing or solidification. Then fourth question: vaporization. That is, you underline this word. Vaporization is the process of conversion of substance from liquid to its vapor state by any temperature below its boiling point. Then fifth question: dash is maximum in gases and minimum in solid kinetic energy. Kinetic energy is maximum in gases and minimum in solids. Okay children, I have given only 5 fill in the blanks. So you write fast, write this neatly. The handwriting should be neat, okay? And keep your notebooks safe and neat also. Study everyday classwork and also study everyday lessons. You must cooperate with us. Okay children? Okay, now I am giving some advice to you. Eat healthy food. Obey your parents. Do everyday work. Okay. Take bath, have a bath. Wash your hands often. Brush your teeth. You must take food. Along with that, fruits, juice. I am not saying 7-Up like that juice. I am not saying that. Juices, that vegetable juice or fruits juice you can take. You should not go out of home. You must stay at home, and you can read the book. Reading book is a good exercise to make your vocabulary. So you must read a book, okay children, and you study also. Thank you children. Through the next we will meet next through the next video. Thank you.